One of the interesting things about our imaginary numbers is that they don't really follow the rules of real numbers. They don't follow the same rules. For instance, if I were to list out powers of 2, 2 to the 0 power, 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power, and we'll go as far as 2 to the sixth power. And what we can do with that is list their equivalences. So 2 to the 0 power, any number to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4, and we should know these. 2 to the third power is 8. Fourth power is 16. 32. And 2 to the sixth power is 64, and I can keep going. 2 to the seventh power would be 128. 2 to the eighth power would be 256, and so on and so forth. So part of the rule that defines this progression, part of the rule that defines this series, is that notice that my number is constantly getting bigger. As I go down in the series, my number is getting bigger and bigger and bigger. Let's see what happens when I do the same listing for powers of I. So we'll say I to the 0 power, then look at I to the first power, and then I squared, and then I to the third power, I to the fourth power, I to the fifth power, and let's go as far as I to the sixth power. Well, we know that any number to the 0 power is 1. That's a definition, right? Any number to the first power is itself. So I to the 0 power is 1, I to the first power is I. Now, by definition, if in the last video we defined any number or a number such that if you squared it, you would get -1. So it stands to reason that I squared is -1. Now let's use some reasoning ability here. I squared, I to the third power is I squared times I, and I squared is by definition -1, so -1 times I is just -I, correct? So I to the third power is -I. Let's take a look at I to the fourth power. I to the fourth power is I squared times I squared, which would be -1 times -1, and negative times a negative is a positive, so that would be a +1. Okay. Let's try I to the fifth power. Well, if we take this, this is I to the fourth power, and then we multiply that by I again, then 1 times I is just I. I to the sixth power would then be, okay, well, we'll take I, and we'll multiply it by I, and, right, this is I to the fifth power here. That's equal to I to the fifth power. So I take I to the fifth power, multiply it by 1. So I'll take I and multiply it by I, and I get I squared. But we know what I squared is. I squared by definition is -1. That's odd. What do you think I to the seventh power is? Well, if I to the sixth power is -1, then if I'm multiplying one more I to get I to the seventh power, then that would just be -I. So I to the seventh power is -I. And if you're paying attention, you see a pattern here. And the pattern is this. There are 4 phases to the value of I. And then once the phase is complete, it starts over as another phase of values. To that end, what do you think I to the 8th power would be? Or I to the 78th power? So what we know about powers of I is that I to the 0 power is the same thing as I to the 4th power, which is the same thing as I to the 8th power. And all of that's equal to 1, and that keeps going, right? That's the nature of phasing. So we start at 1, we end at -I, and we start at 1 again. Very different from the powers of 2, which keep growing consecutively. The powers of I grow to a certain point, and even they kind of bounce back and forth between growth and contraction, and they end up back at 1 and keep going from there. They just go in a phase of 4. So if I were to take I to an arbitrary power, say the 78th power, and try and figure out where it's going to land on that phase, the quick and dirty way of doing that would be to say, okay, well, if I take the number 78 and I divide it by the total number of phase values I have, which is 1, 2, 3, 4 different phase values, then what do I have? So 78 divided by 4 is, let's see, 1, give me the 4, subtract that, 3, bring down the 8. Told you long division would come into play again, and you didn't believe me. 36, that's 2. So I have a remainder of 2. So what I have in I to the 78th power is the same as saying I to the 76th power times I squared, right? And I to the 76th power is 19 different instances of 1. So basically I've got 1 times I squared. And we know what I squared is. I squared is negative 1. So I to the 78th power is negative 1. In order to solve for any arbitrary value of I, you divide that exponent by 4, take the remainder, find that value on your list, and that is the value of I to the power.